Tens of thousands of years ago, on the territory of the uninhabited Sahara Desert, gardens flourished, rivers flowed, ancient people cultivated fertile lands. However, we know how it all ended. Today, in this place is a desert scorched by the blazing sun, with an area 38 times the size of Great Britain. However, humanity has a chance to return life to these lands again, and as a bonus to receive free electricity for all the inhabitants of the planet. The installation of wind and solar farms could radically change the climate in this region, more rainfall which will lead to a revival of vegetation and a drop in temperature. At least that's what Yang Li, the study's author and senior researcher at the University of Illinois, says. No mystery. Wind turbines facilitate the diffusion of hot and cool air. This in turn will raise the average rainfall by 50%. And solar panels absorb most of the solar energy, preventing it from overheating the Earth. All this will be effective only with the global development of a lifeless desert. The process has already begun, but they tried repeatedly to tame the cruel and hot sun of the Sahara. One of the pioneers in the solar energy field who became interested in the potential of the African desert was the American Frank Schumann. From the beginning of the 20th century, he began to bother with solar motors, which would have replaced the then expensive coal-fired steam industrial equipment. Schumann developed a project for a powerful solar machine with an output of 1,000 horsepower, but this required at least 15,000 square meters of the area and $40,000. He found all this in Egypt, which was at that time the colony of Great Britain. The first launch of the solar machine took place in June 1913. It pumped thousands of liters of water for free without the use of expensive coal. Noticing the success of Schumann, the German embassy reported on the project personally to Wilhelm II, since Germany also had colonial lands in southwestern Africa. Germany allocated 200,000 marks for the construction of another solar station. The first project would have received tremendous development, but this was 1914. The beginning of the First World War. Naturally, a lot of money received for the construction of solar factories turned into waste paper. After the war, America had no time for solar stations, since there was enough of its own oil and Europe licked its post-war wounds for a long time. Hence, the project died. But the sun and its potential remained. The interest in solar energy against the background of cheap oil was negligible until the beginning of the 21st century. Only then did humanity take it seriously. Taking into account modern technologies, one solar power plant with an area of 60,000 square kilometers, and this is the area of Holland, in a few hours will be able to cover the annual electricity needs of the entire planet. Sure thing with investment. And again, Africa looks like an invaluable springboard for the construction of the most powerful solar power plants. In 2006, Gerhard Knies, the German engineer, began to promote the main ideas of Schumann. He managed to organize in 2009 the Desertec Industrial Initiative Consortium, which includes such capital sharks as ABB, Deutsche Bank, Siemens. The project involves the transformation of the deserted Sahara into a huge power plant, which will become part of the global electricity generation system. The network will include 20 wind farms, 7 hydroelectric, and 11 thermal power plants, which will provide the territory of Europe, Africa, and Asia with cheap electricity. The bulk of solar stations will be concentrated in the Sahara, Nubian, Libyan, and Arabian deserts with a total area of 14.5 thousand square kilometers. Desertec was expected to meet at least 15% of Europe's electricity needs. With the power plants running at full capacity, Desertec could generate up to 100 gigawatts of clean energy. Energy supplies to Europe will be carried out via submarine high-voltage direct current lines, and only at the points of consumption will they be converted into alternating current. The fact is that when transporting an alternating current of 750 kilovolts to another continent, which is several thousand kilometers, up to 60% of the energy is lost. There are also losses incurred in the transmission of direct current, but they are insignificant. The price of 1 kilowatt-hour of such electricity will not exceed 5 euro cents. It's no secret that the project will work at full capacity only by 2050, when all 42 facilities in the Sahara and the Middle East will start operating. Today, we are working on layering a copper cable with a cross-section of 1,600 square millimeters. A linear meter of such a cable, due to a lead screen and a steel armor double jacket, weighs 40 kilograms and costs $1,100. The total length of the line along the bottom of the Mediterranean Sea is 6,000 kilometers, and the total budget for the project is 210 billion euros. It's too expensive for one organization, but participation in the Desert Tech project has already been confirmed by Algeria, Egypt, Jordan, Libya, the United Arab Emirates, Saudi Arabia, Syria, and Tunisia. In 2014, a 500-megawatt solar energy farm was put into operation in Tunisia. It has become a kind of open-air laboratory, in which in practice the effectiveness of all types of devices for converting solar energy into electricity is tested. Well, let's wait 30 short years, and no matter where we live, from Oslo to Jerusalem, every house will have at least 20% of the electricity received in the Sahara. At least that's what the Desert Tech company promises. But it's not the only one though. Dozens of companies are already investing millions of euros in African electricity.